Question 1b. So now we want to compute the second order Taylor approximation for each critical point AB. So from lecture you should have learned this, which is that the second order Taylor approximations, they look like this for all possible AB. So in this specific example, you want to consider what happens when we're at critical points AB. So at critical points AB, the gradient is already 0. So this part of the formula becomes a little bit redundant. It essentially doesn't appear in this case because we're working with critical points. Okay. And this part here, that's the Hessian matrix applied at AB. So what's the Hessian matrix? The Hessian matrix is HF, and it's the second ordered partials. So like this. Okay. So what we want is to now compute this second order Taylor approximation when AB is 0, 0, 0, 1, and 0, minus 2, as we found in question 1a. Those are the critical points. So case 1 is for AB equal to 0, 0. So then we have the Hessian matrix. Let's just get this one out of the way. The double derivative. This would be equal to, if you scroll up a little, right? Take the second partial with respect to x, you just get 2. If you do the mixed partials, you're getting 0. And the second partial with respect to y is just 36y squared, 24y, and minus 24. So that's just going to be a 2, 0, 0, 36y squared, minus 24y. No, plus 24y minus 24. Let me double check that. Yeah. And in this particular case, where we're working with AB equals to 0, 0, so the Hessian at this particular choice of AB, it simplifies even more. So in this case, it's just going to be 2 and minus 24 on the diagonals. Okay, for this particular case. And then now we recall this giant formula up here, and we make good use of it. So P2 at 0, 0, AB is 0, 0, at xy is equal to f at 0, 0. I already explained that the gradient is just 0 in this case. And 1/2 Hessian at 0, 0, dot, not dot, matrix multiply xy. Then you're taking doing that with the dot product of xy. So this looks a little bit interesting, but if you go back up here, this notation you're seeing there, the brackets, that's just asking you to do the dot product. So we simplify. So f of 0, 0, I believe is just 0, nothing to it, plus a 0, plus 1/2 2, 0, 0, that's a 0, minus 24, matrix multiply the xy, then dot product with xy. Scroll down, simplify. So that's 0 plus 0 is 0. 2x minus 24y. Dot product, x with a y, and simplify. So that's 1/2 2x squared minus 24y squared. Scroll down. X squared minus 12y squared. And this is the second order Taylor approximation at 0, 0. So I'll write that down. P2, 0, 0, xy. This is the second order Taylor approximation. Okay. So now the question asks us to do it for the other critical points as well. So we're now done the case where a, b is equal to 0, 0. Next case, for a, b equals to 0, 1. Yes, okay. So p 0, 1 xy, the function at 0, 1, the gradient is just 0, 1/2, and it's the Hessian, which was just 2, 0, 0. So if you just scroll back up to the Hessian for a sec. So it's 36y squared plus 24y minus 24. So 1 squared is just 1, right? 36y squared, 24y minus 24. We have that matrix multiply the xy. Dot product xy. Simplify. So that's just going to be, what was it? X squared plus 3y to the power 4 plus 4y to the power 3 minus 12y squared. And then a plus 0, which is this 0 there. And then we simplify. So what is it going to be? 1/2, 1, 0, 18? Okay, 18, 0. Oh, yeah. I don't need to write the... Sorry, I tried skipping a step. It should be 2 and 36. I went a little too fast for my own good. Okay, so we simplify this part. We're going to simplify that part. And I think you just get a minus 5, because it's 7 minus 12. And a 1/2, this part's just going to be 2x squared, 36y squared. And then you simplify that, minus 5 plus x squared plus 18y squared. And this is the second order partial at 0, 1. Sorry, the second order Taylor approximation at 0, 1. Okay. So next, the question asks us to do it for the third critical point, which is 0, minus 2, I believe. Yeah, 0, minus 2. Okay. So P2, comma 0, negative 2. There we go. XY. And that's just f of 0, minus 2 plus 0, because the gradient is just 0 in this case. 1/2 the Hessian, which is 2, 0, 0. What was it? 36 y squared plus 24y minus 24. And we matrix multiply that by xy, and then we dot product it by xy. So let me double check the Hessian. Yeah, I got it right. So 36y squared plus 24y minus 24. And in this particular case, y is minus 2. So we just do as before, we simplify. So f of 0, 2 is just minus 32. It's nothing special. And then 1/2, this part will be 2, 0, 2, 0, 0, 72. You just simplify, nothing special. Matrix multiply xy, dot product xy. And then we continue, so minus 32 plus 1/2, 2x squared, 72y squared. Simplify that. Minus 32 plus x squared plus 36y squared. So this leads us to the end of question 1b. And what I've computed for you there is a second order Taylor approximation when at the critical point of AB, when AB is equal to 0, 2. And that's it for 1b.